we're over here at the Monarch lathe, and this is a piece I found in my scrap. It's got a nice plug on it, and so we're going to chuck that up in the lathe here. I got it cleaned up, and this is going to be a backing plate. What I'm going to attempt to do is, this is one of the grinding discs from the Accu-Finish. It's got a 1/2-inch hole in it, and then it has the drive pin, and these are 438 thousandths thick. Well, these are very expensive. So my plan is, I've got this aluminum disc here, and it needs a 1/4-20 tapped hole when it's used on the Accu-Finish. So my plan is, I'm going to mount this guy on here, get it down to the right thickness. It's too thick, it's a 1/2 inch right now. This needs to be a 1/2 inch hole with the chamfer. And then I bought these diamond discs that already have a 1/2 inch hole. So my plan is to go ahead, get this to size, get it all mounted, and I'm going to put magnets into here so that this will just magnetically go onto here, and you can remove them and leave the platen in the grinder. And then the second thing is I'm making this one for doing end mills and reamers, mainly end mills, is that this edge will have a 30-degree back bevel on it. So that way when the end mill goes by, hang on. So when the end mill goes, when you're sharpening, when the end mill goes by, you're only catching just the center of it, and there's nothing back here. There's not a deeper edge that'll catch the end mill. It's actually a copy of Accu-Finish, is what they sell. So with that said, I'm not going to show machining. I'll show progress. You don't need to see me clean up this plate. Just standard stuff, right? It drives me nuts watching that. I know when I was learning, I watched every second of everybody turning something. I'm not going to do that to you guys, and I'm not going to do it to myself to go back and actually do the production on the video. Okay, so just to say here, what we're going to do here is clean this face up. We're going to drill and tap it so that we can go ahead and mount the piece of aluminum on it and get started on that. Okay, just what I mentioned. Went ahead, clean the face up on this, and we'll move on to the next step. Well, just bypassed one bozo. I was saying 1/4-20, but it's 5/16 18. I double checked myself, so I've got the whole board and threaded for 5/16 18, and we'll move on. So we're over at the drill press. Got a gauge pin in here. This is where the float lock vise works real nice. Go ahead and get this guy lined up on that gauge pin and lock it down and drill the clearance hole that I need to drill through there. Make sure I didn't move it. I tightened it there. It's good. And then a couple of little wood spacer blocks. Since we're only sitting on 2 edges on there, be nice and firm. And this is the clearance hole for the 5/16 bolt. over to the lathe. Hey, you got to watch the machining there. Okay, you got the clearance hole drilled. 5/16 18 Allen head in there, so I've got room, and it's on the backing plate there. And so next is I got to take it to thickness, which is 438.438, and it's at 5/18 right now. And also you get the diameter down to the right size, and then cut a 30-degree back cut on the edge here. So we'll bring you back. Just a little in-progress shot, throwing aluminum everywhere, but I got about another 50 thousandths to go to get the plate to the thickness that it needs to be. Then I still need to do the diameter in the back bevel. Well, I think you can see the DRO. It's got me at 402/10, and micrometer says 399.225. So really happy with that. Finished with like a 10 thousandths finish cut on it, and plate's ready now to go to diameter. Well, you know I'm a tool nut, and so years ago, Adam Booth, showed the in-size calipers. This is a 12-inch one, and the tool nut that I am, I had to go buy it. I honestly don't know if I've ever used it. The battery was dead in it. I know it's been sitting in the drawer for a long time, but hey, I got it when I need it. I do have 6-inch calipers, and I've got even bigger calipers, but thought I'd pull this one out. There's a little backstory for you. So I'm looking for 6 inches, so 217 thousandths has to come off. Okay, got the diameter left at 50 thousandths over 6 inches, just so when I cut the 30-degree, I may be taking that out, so I left myself some room. Okay, the lathe work is done here. I tell you, you got aluminum everywhere. Got the disc turned down, got the 30-degree angle on it. What's wrong, Howie? And I don't know if you heard him groaning in the background there. So now it's on to the finish up the hole, and I got to put the other hole in to hold the disc. And then I'll probably size it one last time once I get everything done. Well, Howie came in to see me. He turned 11 yesterday, and it's 4 o'clock, and he's going, "It's time for dinner, Pops. Get back in the house." But just to show you the mess out here, and you're turning aluminum, and it's flying everywhere. So time to do a little bit of cleanup. But we'll bring you on. Well, we're over here at the mill, and this is one way to find center. Just having some fun. So, get the light on. Come on, lights. So I had the bolt in there, got it centered up on the hub that was in the lathe, clamped it, pulled the bolt out, and now I can continue on. Got quite a stack there. My pallet, the rotary table with a pallet with a 3-jaw chuck, with another pallet for my part. It all works so. So as you move the quill, of course the circle gets bigger, gets smaller. You can also direct the head and make it bigger or smaller. I could, if I want, actually indicate out here on the very far end of this. So that's the half-inch hole. I got to put the countersink in for the tapered head, and then offset and put in a hole for the pin. Okay, got the countersink done for the 5/16 18 thread. Next is do the offset for the pin, and then the magnets. Got the hole drilled for the pin. That's completed. Okay, I've got the holes drilled for the magnets, 3 of them, and the magnets are 8mm, and I don't have an 8mm end mill, but I do have a 21/64. It's not center cutting though, so you can see it's got a hole there, so it left a little pin in each one. So I'm just going to go back in with a smaller end mill and pop those off. Pretty amazing. 21/64 is in the drawer. Okay, probably hear the compressor running in the background, but magnets are all set just below the surface. Perfect. Really happy with it. Chamfer screws perfect. Got my drive pin lined up, and so I got to glue the magnets in and be ready to set the disc on it. Well, this will be a first for me, surface grinding aluminum. So haven't used the surface grinder in months, so just letting it sit here and cycle and get as warm as possible. It's 50 degrees in the shop, so we'll bring you along. Okay, here goes nothing. Let's see what happens. So I just touched there. Get the coolant going, and then we're going to sweep across. Anybody want to check my pulse? Christ, what is it? 96. A little nervous. Started to make some interesting noise there. That's why I pulled off. It's looking nice. I just got it. It's not even a thou that I need to take off of it. And that was the high side over there. Alright, go back at it. Ah, bark, 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 bark. Almost to where I was. Sparks are the magnets that are in there. Hopefully they'll stay in there. my pulse. Nervous Purvis. 95 still. Let's see what she looks like. Kind of cleaned up the whole way. Cooling off. Well, if I was nervous earlier, grinding on aluminum, this one really adds to it. So, I've got the aluminum plate sitting up on some parallels below. I'm using 1/4-inch tool bits to pack it in, and then since I have a 1/2-inch hole here in the center, I machined a plug that is down onto the magnet and below the surface of here. So it should prevent it from taking a flying. So let me get everything going here, and we'll see if my pulse stays down. Well, I think it's a success. You can see I didn't grind all the way to here. Only the center portion is what actually rests on the drive. The rest of it's just out in the air, so it doesn't really matter. So hopefully I've got this guy done well. It didn't move. Let me drop the magnet. And there's the pin that I machined for underneath to bite on the magnet. Come on, it's got some grit in there. But anyway, that's what held it so it couldn't slide. I get it cleaned up and see how it did. Well, we have success. They're sitting on 0. I got maybe a thou, total thou run out, which I'm very happy. I had about 4 thou run out before grinding the back side of that platen. So now I just got to finish up with getting the pins in it so that I can mount the actual diamond surface. We'll bring you back on it. So here's another problem I need to solve, or I've solved it, but I don't know why. But the countersunk bolt is in there and it doesn't tighten. I pull that guy out. You don't need to see the indicator anymore. If I pull that guy out, you know, for some reason, it's just not, I just don't understand my chamfer there, to be honest with you. So on my laser, I cut some shims. .3/1000 thick shims. If I put that guy in there with the shim underneath it, come on. No more wobble. I have no wobble. So I just don't understand the problem with the countersink. I could put it back in the mill and go a little deeper on it. Maybe. I gotta do more homework on it and figure it out.